Swayam Prabha. Digital India. Educated India.
Dear students, now again we are starting our interaction on the geometric design. We have started with the side distance requirements, and so far we have talked about the various factors which affect the side distances. And the last interaction we talk about the factors related to the friction, related to the maneuver time, the relation between the speed and the friction coefficient, the maximum acceleration rate which is again related with the speed, and the heights of eye level, object, headlight along with the angle of the beam through which the light is coming, and then we are going to get the visibility ahead of the vehicle during the night time. With these factors in mind, as I said that some of these factors will affect a particular type of a side distance and some others are going to affect the another type of side distance. So, in this direction today we are going to talk about the stopping side distance, and this stopping side distance we will be talking for the different conditions which can be talked as carriageway widths, the leveled surface versus the gradient surface, or the efficiency with which the brakes are being applied, and finally we need to see that how the combination of all of these conditions are going to make a difference for the stopping of a vehicle in a given situation. So, let us start with it. The stopping side distance. Now, this distance is the distance which is going to be available ahead of a vehicle to a driver to see that was it actually happening on the surface or on the road or on that particular lane, and then to stop the vehicle just before hitting the object, which can be either an static object or it can be an object which is dynamic in nature. That means, this object may be simply lying at one location on that lane or it is moving there, and if that is happening then there are possibilities which can be also done. We talked about this type of a situation in the one of the previous interaction also. The extreme condition will be that if nothing is happening, if there is a person and this person keeps standing on the road and say the person is talking on a phone and is not aware that the vehicle is coming, then what this driver should do? When this driver sees that this person is not changing its location and he has already moved a certain distance, during visualizing whether this person is going to change the location or not, now no option is there and the vehicle should stop by this position, so that this person is not being hit, and that becomes the most extreme condition. What can be the alternate here? That this person is not moving, standing here, then what we can do is that we can start reducing the speed of the vehicle and try to wait that this person will move. Or another case can be that we have to change the trajectory itself and we can go in this direction and just overtake that particular person's location and an object's location and thus avert the crash which otherwise could have happened at that location. So, the two things have been talked here as the alternate conditions. One is the change of path and another one is the reduction in the speed so as to suit the condition and omit the situation. So, what does that mean? The driver is trying to visualizing the situation, the driver is trying to understand it, and then the driver is trying to take a decision, and that is what we talked when we talked about the PEEV theory. And the extreme conditions if they appear, then we said that there is an impulse which is going to be there in which the driver is going to take a extreme decision all of a sudden. So, this type of visualization, understanding the situation and taking a decision does what is that it tries to divide it into two scenarios as being shown in the photograph, One is that the person is trying to visualizing, that is, this is the case. Another one is the person has taken a decision and is now acting with respect to decision, and is the next case to follow. Now, when we are looking at the calculations of this safe stopping side distance, we try to see that under the worst conditions what needs to be done. So, let us move ahead and see that how these things can be calculated. So, here what we see is that this is a vehicle which is at this location, say A, visualized an object which is there at a location B. The height of the eye of the driver is 1.2 meters. The height of the object is 0.15 meters. If it is less than this, then we are not considering as such, and therefore, we are trying to calculate this SSD, and as per this diagram, this SSD is going to be divided into two parts, and those two parts are defined here as lag distance and braking distance, or reaction time distance and braking distance. So, lag distance or a reaction distance, they are going to be the same thing. Now, we have to calculate these values. Now, when the vehicle is moving here and is trying to understand, it means this vehicle is going to move with the speed of V meter per second continuously while visualizing the object and try to understand it. So, no change in the speed is there, this vehicle keeps moving up to this point as V meter per second, and by this time there is some time t which has elapsed, and that time t was what? The PRT, the perception reaction time, and we talked about that perception reaction time. If you remember, we said there is a range of 85th percentile values, and within that if we consider 2.5 seconds, then it covers 90% of the cases. So, when you are looking at this condition, then this lag distance is the distance which is travelled during PRT at a design speed for the facility. So, if the design speed is being talked in terms of V kilometers per hour, where the V is in capital, or meter per second where the V is a small, which when we transform can be 0.278 into V, and PRT is t seconds, then the lag distance is going to be in a simpler form small v into t. So, your seconds cancels by itself and you are left with the distance in meters, or otherwise 0.278 into capital into t, and that is again you are going to get the value in meters. When you talk about the braking distance, as I said that when the vehicle is moving and it has moved with a speed of v continuously for a distance which is lag distance during the time t, which is the PRT. After that, here under the extreme condition, this vehicle has to stop just before the obstruction, and therefore, the V becomes equals to 0. So, this braking distance is the distance which is being travelled after the application of brakes and before the collision takes place. So, the change in speed is from Vd to 0, and this Vd is nothing, d is for the design. So, we have talked about the design speeds, and if you remember, we talked about that design speed in the case of national highways in the plain terrain as for the rolling condition or the minimum 100 or 80 kilometers per hour, but when you talk about the arterial roads, subarterial roads, then they become lesser and they may be like 60 kilometers per hour, 50 kilometers per hour, 40, 30 kilometers per hour. You need to revisit those values to understand that. So, we are now interested to look at this braking distance to find out what is going to be this, and this braking distance is going to be defined on the basis of the rule that change in kinetic energy, which is there because of the change in the speed from Vd to 0. And the another thing is because you are going to brake and you are going to stop your vehicle, then the work done due to the frictional force, and these two are being equated. Now, the frictional force is nothing but it is a coefficient of friction F multiplied by W, where W is the weight of the vehicle as being defined here also. And when we are comparing these with the change in kinetic energy, obviously the last one is a 0 value. So, we are left with mv square by 2, where this v is related to Vd, and then this is equals to F into W into distance travelled before stopping, and therefore, the distance travelled before stopping is going to be small v square divided by 2 gf in meters. And this F is the coefficient of longitudinal friction, which we have seen that it is dependent on the speed, and it was changing from 0.40 to 0.35 as the speed was changing from 20-30 kilometers per hour to 80-100 kilometers per hour. G is the gravitational acceleration and this is 9.81 meter per second square. So, now once you have got both the values, so what you have is SSD will be small v into t plus small v square divided by 2 g f, and this v again we can say that they are related with the design speed, or this can be v d or v square divided by 254 f, where g is being taken as 9.81 and the v is being transformed into capital V by way of the factor. So, this is the way we are going to calculate the value of SSD on a leveled surface. Now, when you are talking about a leveled surface, then still there can be a condition. Say you have a road which is single lane, and therefore, this is having a width which is quite less, something like 3.75 meters, and there is a vehicle moving in this direction and there is a vehicle which is moving in this direction. They both see each other, and when they both see each other, they want to stop before collision, and this is the point where the collision can take place. It means this vehicle as well as this vehicle, they should move by a distance SSD so as to stop before collision. So, if you have a single lane two-way traffic conditions, then the SSD is going to be the twice the value which we have calculated by the formula which we have seen in the previous slide. But when you are talking about the two lane two-way carriageway, then both of the vehicles will be moving in their own lanes. So, you have this vehicle which is moving in this lane, and then this is another lane, and then another vehicle is there which is moving in this. So, in case there is any obstruction at this point, this vehicle has to move and stop by here, and this vehicle has to stop by here. Therefore, for an individual vehicle, this is nothing but it is a single value which is going to be there. In the case of divided carriageways, then what we are going to find out is that it is the SSD which is to be provided, because this SSD, this is the minimum value which has to be provided under any of the condition. But it is always better to provide twice of SSD on each lane. The reason being, all of these vehicles on the divided carriageways, they will be moving at a very high speed of 80 or 100 kilometers per hour, and if there is any condition under which a vehicle which has been ahead has stopped, because of these high speeds, the driver of this vehicle will not be able to visualize it better and to see whether that vehicle is moving or not, and so as to create a better condition of safety, we can provide twice of the SSD on such lanes, but minimum will always remain equals to SSD. Here what you can see is that for the given design speeds changing from 20 kilometers per hour to 100 kilometers per hour, first of all the perception reaction time is being given, and this for this time the distance has been calculated, and you can see that the time is constant unless and until under the experimental conditions we have found out that they are different, and for that by way of simple multiplication of small v into t, where the small v is in meter per second, we are getting these distances. And then there is a change in the coefficient of friction in the longitudinal direction, as I said, and again we have got the values, and then finally these are the values which have been rounded here to vary from 20 to 180 meters. So, what you found is up to 30 no change is there, then if you are going to 40 then it increases by 5, if you go to 50 increases by 10, if you go to 60 increases by 20, if you go to 80 then this is increases by 40, and if you go to 100 then increases by 80. There is a simple thumb rule with which you can work also. If you are not calculating, you have to simply see that what can be the value. Here we have an example, and let us look at this example. We have a traffic which is moving in a road, the speed is being given as 65 kilometers per hour, PRT is given as 2.5 seconds, the factor F is being given as 0.36, which is the coefficient of longitudinal friction, and we have to calculate SSD for the three given conditions. Now, whatever are the given conditions, the very first thing which we need to do is to calculate the single value of SSD, and that is what is being done here. So, it is 0.278 into capital V into t plus V square divided by 254 f, because this value we are directly using in kilometers per hour. So, when we use these values, and when we put PRT as 2.5, F as 0.36, what we are getting is 91.380 meters. Now, the first case is a single lane one way carriageway. So, let us look at that first case, single lane one way carriageway. That means what? The traffic is moving on this and you have the traffic which is going only in this direction. There is no traffic coming from here. If there is an obstruction, then this vehicle should stop by moving a distance of single SSD. Therefore, if we consider that, the answer is going to be 91.38 meters only. But if it is a single lane two way carriageway, as we talked previously, this needs to be doubled, and when we double it, it is going to be 182.76 meters. In the case of two lane two way carriageway, because the vehicles are moving in their own lanes and therefore, again a single SSD will be sufficient for those vehicles. So, that remains 91.38 meters. So, what conditions have been given to you, accordingly those values can be calculated. Let us look at the effect of the gradient. So, the vehicle is moving here in the upward direction and there is a gradient theta which is there, whereas in this case it is going in the downward direction and the theta is there. So, this is a design speed with which the vehicle is moving, and when we take the components, so this is nothing but this is the weight of the vehicle which is acting vertically downwards. So, this angle is going to be theta, here this angle is going to be theta, and then we transform the value of mg with the perpendicular to the surface and parallel to the surface. What we get is mg cos theta and mg sin theta respectively, and their directions are going to be like this in the case of upward or downward direction. So, what is happening is there is a role of the friction, there is a role of those components which are there, and on the basis of that we are going to get certain values in terms of SSD on a gradient. So, let us try to see that what happens if we are going upwards and what are the directions of these forces and how we can find it out the value of SSD by way of the calculations. Now, when you are talking about PRT, PRT is going to remain same. The driver is looking at a situation for 2.5 seconds and moving with a speed of Vd, and therefore, it is nothing but Vd into T will give you PRT distance. But here we are talking about a braking distance, and braking distance is that this force mg sin theta is working in the backward direction, and when you talk about this force which is normal to the surface, it will culminate into the frictional force as F mg cos theta. So, you have two forces which are acting backwards, and there is a force due to the speed of the vehicle which is acting in the forward direction. So, mv square by 2 when it is going to stop as v is equals to 0 by this position on the surface. So, the change in the kinetic energy is mv square by 2 is equals to mg sin theta plus F mg cos theta, and here you can cancel the value of m, and while cancelling the value of m, what you are left is the braking distance is v square divided by 2g into sin theta plus f cos theta. We can keep it in this form or we can transform it into a tan theta situation, and then in the case of these angles with which these are being provided, so whatever the longitudinal gradients are there, they are not very steep, they are very small. In those small conditions of theta, what we have is that these theta they are going to translate into, or this we can say as theta also. So, theta or n or tan theta or sin theta, they are going to be same. So, finally, what we have is v square divided by 2g into n plus f. This f is being added with the effect of the gradient, and this gradient will be in fraction. So, if you say that is a 1 degree, so 1% gradient is there. So, 1% gradient is being talked as 0.01 here, and it is being added to 0.35 to 0.4 depending on the speed with which the vehicles are moving. So, you get an equation v into t plus v square divided by 2g into f plus n. So, this is for an upward movement. Now, let us look for the downward movement. The only difference which is going to be there is because of this situation, where now still the mg cos theta will be perpendicularly downward, but mg sin theta has changed the direction, and therefore, the frictional force is backwards and this is getting reduced from there. So, the frictional force is reducing, and that is the reason that the speed keeps increasing when you are going on a downward movement on a gradient. So, again the same thing has been done. So, we have the change in the kinetic energy versus the braking distance multiplied by the the factor which is going to be there. So, this is f into mg into cos theta minus mg into sin theta. So, now it has become negative because this is moving in this and this is moving in this direction. We are looking at the force in this direction. And then finally, the breaking distance which we are left is v square divided by 2g into f cos theta minus sin theta or f minus tan theta. Again considering the same assumptions, what we are left is v square divided by 2g into f minus n. That means the effect in the case of downward movement is negative here of the gradient, which is a percent gradient. So, what you get is SSD is v into t plus v square divided by 2g into f minus n. So, now we have got two conditions, one for upward condition, one is for downward movement condition, and together what they are going to provide is this equation, that is v into t plus v square divided by 2g into f plus minus n, where positive is being used for upgrade and negative is being used for downgrade. So, when you are going upward, if it is positive, it means it is going to reduce the distance. When you are going downward, it is going to increase the distance by certain value. If you are using it in capital V, that means kilometers per hour, then the simple change is 0.278 v into t plus v square divided by 254 into f plus minus n. Now, when you are looking at again the different conditions in terms of the carriageway, then here the effect of this gradient is not going to be considered in the case of undivided carriageways, as the effect is increasing on downward and decreasing on upward movement by equal amounts. So, because of this reason, there is no requirement even to use the formula which is being given in terms of SSD related with the gradient. You can use the simpler formula, because whatever is positive is going to be negative. On an average, you get the same SSD together. But in the case of divided carriageways, we are going to look at it because now the movements are in a specific direction and either they are going to reduce or increase depending on whether you are going up or down. So, let us look at another example here. Here the vehicles are moving at a design speed of 80 kilometers per hour, the gradient is 2%. The PRT, you can see that it is being defined as 3 seconds, maybe on the basis of some experiment done on that particular road. The friction coefficient in longitudinal direction is given as 0.35, or otherwise we can take it from the table. Again we have to calculate the SSD and the three conditions have been stipulated here. So, what we are going to do is that we are going to calculate the value of SSD for the three conditions. One is the leveled condition, another one is on a gradient when you are moving up or when you are going down. So, when you are using it for a gradient, then the equation was this one, and when you are going upward, then we are using positive. So, we are using positive here, and on the basis of these calculations, by putting it the values, what we get is 134.82 meters. When I look at on the downgrade, then the value is going to be negative here, f minus n, and what we get is 143.07 meters. So, previously we got 134.82 and now what we got 143.07 meters. You can see that the value is increasing. And what is happening if you are on a leveled section, then in the leveled section we are not considering the value of this gradient, and what we get is a value 138.71, which is almost in between these two values, and that is why I said that if that effect is not to be considered, then even the value on a level section can be utilized directly without putting the value of gradient and using the bigger equation. Now, what three conditions are being given? Single lane two-way carriageway. So, single lane two-way carriageway, the traffic is moving on this case. So, what needs to be done? So, the traffic is, one vehicle is going up, another vehicle is coming down. In one case it is reducing, in another case it is increasing. So, in that sense what we can say is that for a simpler value of a level section, we can take that and take the twice of that value is going to give you the value for SSD here. When you are talking about a two lane two-way carriageway, in the case of two lane two-way carriageway, whatever the values are there in a particular direction, we can utilize that. So, this is this, but in the case of four lane divided one, we are considering it separately, and therefore, for a downward and upward condition we have to specify it separately, and this being specified here as 143 and 134 meters, and you can make it rounded also. So, we can say finally that it can be 145 meters and this is 135 meters which needs to be provided. Now, let us come to the condition of braking efficiency. So far what we have been talking is that we are applying the brakes with the 100% efficiency, and therefore, we are going to stop with the minimum distance to be travelled. But if we are not applying the brakes with the 100% efficiency, then it is going to make a difference only to which particular side. We have two components here. One is lag distance, wherein we are moving with the design speed during the time which is PRT, trying to understand the situation and then taking a decision to do something, and that is what is being done here. So, what is the change which is coming here is the incorporation of this neta value, which is the braking efficiency in friction. So, it becomes V into T plus V square divided by 2G into neta into F plus minus N if there is an effect of the gradient also. So, this becomes a composite equation. Now, what effects are being given or what are not being given, accordingly we can change it. Now, if we look here and we looking at this design speed. So, this is again a changing, the factor 254 will come, that is the only change which is going to be there, otherwise the things remains the same. Let us look at this example 3. In this example 3, the speed is 100 kilometers per hour, the gradient is 2.5%, the perception reaction time is 2.5 seconds, the friction coefficient of longitudinal direction is 0.35. Now, we have to calculate again the SSD. The condition is 2-lane two-way carriageway and the braking efficiency is 75%. So, we are considering the equation on a gradient. So, 0.278 into V into T plus V square divided by 254 into neta into F plus minus N. If you are going on an upgrade, then positive is being used and neta is the braking efficiency. So, 0.75 is the braking efficiency is being used here, and what we get as an SSD on an upgrade is 157.52 meters. If I look at the downgrade, then using negative here and a neta 0.75, what we get is 168.52 meters, whereas on a leveled section we get 162.71 meters. So, you can see the effect of all of these type of the conditions which are there with respect to the traffic condition, with respect to the width of the carriageway, with respect to the gradient etc. being provided. And here, because you are trying to find out for 2-lane two-way carriageway, for a 2-lane two-way carriageway, the effect of gradient is not going to be considered, but yes, the effect of the braking efficiency is being considered here, which has given us a value of 162.71. So, what we get is 162.71 meters as a answer. So, this is how we can calculate the values of SSDs under different conditions, and with this we come to the close of this interaction, and we will be continuing our interaction with the calculation of overtaking side distance in the next class. Till then, thank you and bye.